Welcome, Sciton University. This is Ryan and Alex, and we are here to educate you on resurfacing. We're going to talk about the erbium YAG laser that Sciton has on the Joule X platform. So I'm going to pass the mic over to Alex, and he is going to go through his slides. Alex is the product manager for our resurfacing product line, and he is an expert when it comes to understanding resurfacing and how to position it within a practice. So Alex, it's all you.
Thank you very much, Ryan. I'm excited to be here today, team. And we hope, our resurfacing product line, as you can see, is called Resurfacing Perfected. And we hope by the end of these presentations, which we're going to do in 2 modules to break it up and give you a deep breath. And hopefully by the end of it, the goal is that you can see how we've done everything within our power as a company to deserve that name. At the outset, I think it's important to make sure we do a brief disclaimer. For this presentation, we're going to cover literally everything that you might want to know. Therefore, it's required of me to say that this is intended for internal training purposes only. And basically what that really means is please don't screenshot, redistribute, send to clients or prospects. Now, if you are finding the material in this to be that valuable, please just reach out to me. Or for any of the Sciton University presentations, if there's something you want to use, contact your product manager and we will get it for you, make sure it has the appropriate permissions and get it for you in high res. So we have Resurfacing Perfected. Now this covers all of our erbium YAG only laser applications. And there are many pieces of hardware that have changed throughout the years, and we're going to go through everything in detail. But when you see this brand name, that's the suite. That's what you want to use. It's based on the erbium YAG laser. So a lot of this is going to be like, why? Why erbium YAG? And more specifically, why not CO2? So as far as learning objectives, we really want to cover why we're going to use erbium YAG for ablative resurfacing on skin. And we're going to compare it to historic CO2 devices. We're going to go through the section that I like to call the devil's in the details. And you're going to learn how Sciton has managed to engineer this with such specificity that we overcame all the early objections that doctors and users had for erbium YAG. People call it shallow or weak. That's not about our technology. And we're going to discuss how superior engineering overcame those uses. And most importantly, the real power of the Resurfacing Perfected suite that utilizes erbium YAG is the tunability. And what ultimately you'll come to learn is that there are many applications, treatable indications, ways to dial in settings so that you can customize to a patient's downtime. And it's all coming from this one erbium YAG laser modality. And then finally, just as a brief disclaimer, if you're at home watching these, thank you. We'd love you. Stay safe. This particular module is going to assume that you've already had laser physics, probably from Hoopman, and a skin anatomy class, and you've seen Sonia's skin anatomy class. It's amazing. Please go take those first. You'll get more out of this. If you only get one thing out of this presentation, and I like to do this for all my presentations, it's the key take home. I'm just going to read it out. With tunable resurfacing laser technology, that's the TRL acronym that you'll hear, users have the ability to independently adjust the depth of ablation and coagulation on a patient's need. That's now. You're going to independently be able to choose ablation and coagulation. That doesn't mean you automatically get coagulation just because ablation, or vice versa, which allows a lot more control, tunability, hence the name. To discuss why this is, we really have to get into the science. And because you've already had those previous modules, we're going to keep the overview brief. So when light interacts with matter, all light is either scattered or absorbed. And we're going to hear about that because it's important to pick the chromophore or absorption target that you're really going for. And in erbium YAG, that's going to be water. Now you can see scattering affects where the light goes, and absorption affects where the light is turned into heat. And this actually, if maybe this doesn't make that much sense to you, you can think of it in several different ways that are common in your life, right? We get light from the sun. The sun the light passes through windows. That's what I can see in the room I'm in right now. That's forward scattering. Light bouncing off of a mirror, that's back scattering. You see colors, that's because some of the light's being absorbed and the rest of the light is making it to your eye. Laser light. Laser stands for light amplification by stimulated emissions of radiation. Laser light is coherent, collimated, and it is of a single wavelength, monochromatic. A flashlight, by comparison, or our IPL flash lamps before you put a filter in front of them, are non-coherent, polychromatic, and non-collimated. So you can see how this, if you were to overall call that some sort of selection and focusing of light to be a very specific parameter, it allows us to target individual things in the skin. And you may have heard this called selective photothermolysis. Now, we're not going to get into that because that's in other modules, but it comes into play for the important part here, which is that there are multiple different types of ablative lasers. The two most common types are the CO2 or carbon dioxide, and then the erbium types. Now, we use erbium YAG, which is yttrium aluminum garnate, but there's also erbium glass or YSGG crystal, and those are different. So what's really important as you go out there talking about these devices is you remind people, and especially if you're lucky enough to work with our KOLs, this is an erbium YAG laser. We don't want to just call this an erbium laser. And it'll be key when we get to the absorption charts. But to back this up just a little bit, CO2 lasers, now again, the wavelength for this is 10,600 nanometers, were very popular during the mid-1990s because they're practically the only option available for ablative laser skin resurfacing. And they came in continuous wave and then eventually ultra short pulse modes. But really, these lasers are very effective. But if you go back to history, you can quickly realize they were originally made for really impressive industrial machining of like metals and chips and silicon wafers. And therefore, when you take them for skin, they weren't really built for that. And they had some significant side effects, especially if used in inexperienced hands. I mean, if you can give an artist a really bad paintbrush and they can still paint an amazing picture if they're a master. So we're not debating that people use CO2 and they can use it well. But one of the things that we're going to get into on erbium is that we can avoid a lot of these severe complications like prolonged erythema, hyperpigmentation, or most significantly, this delayed onset hypopigmentation. And that was a really big issue because you didn't know it was going to happen until later. And then you basically left someone with porcelain skin, but only in the place you treated. It's a huge problem. So to make up for that, our founders, Jim and Dan, wanted to create a very functional erbium laser. Now, erbium, again, is at a 2940 nanometer wavelength. And shortly following development of CO2, erbium YAG laser was introduced as a better alternative. It was proved to be an advancement of CO2 because it shows a drastic reduction in deep thermal damage due to a stronger water absorption. We're going to cover why that is. Although the erbium YAG laser is very good for skin lightening and leveling, the tissue tightening effect is less than CO2. You're going to hear that a lot out in the field. Obviously, less heat leads to less tissue tightening. But we're going to see why it's important if you use erbium YAG right to be able to get the best of both worlds. When we talk about the wavelength being 2940, that means it's in the infrared. You should be able to see here. Can't see it with your eyes. This will be different from the other, here's CO2. When you hear about Clear Suite, that'll use our 1064 ND YAG, and then these are BBL wavelengths that we select for in the visible, just for comparison. We go to the absorption chart briefly, and if you look at, you remember from your laser physics module, you've got your melanin, you've got your chromophores, all of them, hemoglobin, oxyhemoglobin, and water. Now, what I want you to know is that if you look at the different wavelengths, you're going to hear about halo later. There's 2940 and 1470. You can see how that would be able to target, the 1470 will target hemoglobin, melanin, and water, but the 2940 of erbium is at the peak of water. Now, we're not going to go into basic skin anatomy here because we have a separate module for it. But one of the things that's going to be important is knowing when we're getting into different layers. Because when you talk about heating, as you did in your laser physics course, you can see that per unit energy, erbium is going to be concentrated in a much smaller area shallow to the surface versus CO2. Whereas the 1064 that's used for deep penetration, you can see it's not as much absorbed in water. So wavelength, again, is going to determine your ideal absorption target. The absorption spectra help to determine the wavelengths that you want to heat desired targets. Wavelength also affects scattering that we talked about. So if you're not getting absorption, the light is scattering, whether that's forward or around and spread, that's important. So then when you combine the scatter and the absorption, that kind of determines your heating profile. So again, why do we choose erbium? It's better ablation through more efficient water absorption. Erbium has arguably the highest absorption by water, which allows for vaporization of tissue with very little thermal conduction. And that's how we can achieve less risk of these side effects than what is seen in traditional CO2, specifically the prolonged erythema and delayed onset hypopigmentation. Here you can see why. The CO2 is at the end of the chart here, and this is, this is in log units here. So even though this is only one grid mark, this is about 14.6 times the absorption of CO2 erbium YAG. So the YAG wavelength is at the absolute peak. And then this translates with some engineering tech into much better ability to achieve and select different depths. Now you can see that CO2 does hit a large number of these depths for both ablation and coagulation, but the important thing to note here, and we're going to get into this, is that with our technology, you can pick how deep you want to ablate and you can pick how deep you want to coagulate. Whereas these are going to be inherently linked to each other. When you look at these in comparison and you hypothesize how this would play out in tissue, there's this erbium YAG being 14.6 times more effectively absorbed than CO2 laser energy. This means that you can get really efficient vaporization of tissue. I like to call this the popcorn effect. The energy is going in, it's getting absorbed by the water so quickly that it's ejecting the tissue back out, because that water in that tiny spot, it boils. And when it boils, it increases, becomes a gas, and tissue is ripped back out. On the other hand, with CO2, if this doesn't happen fast enough and there's lower absorption, then some of that energy gets deposited into tissue that wasn't ejected. And then that energy becomes heat. It coagulates and cooks the skin just like cooking an egg in a pan. How does this really play out, or why is this important to the patient? In CO2, up to 40% of patients had an incident of permanent delayed onset hypopigmentation. They had a lengthy downtime with prolonged inflammation that obscured the possibility of these effects. And there was a lack of tunability. The minimum total depth of injury was somewhere around 100 to 120 microns, preventing these low-level peels that you're going to see. Because of our greater than 10 times higher affinity to water, it leads to this tunability that allows you to be safe. You're going to have less downtime, very little to no risk of permanent hypopigmentation, 10x better depth control, and your coag is going to be independent of the ablation, which is going to be very important. So, it's one thing to see a diagram, and it's something entirely different to see an actual skin slide. Now, here on the left, we have an H&E stain. This is a microscope slide of skin. Here you can see, you see your stratum corneum and your epidermis and your dermal tissue. And all this dark purple tissue is dead necrotic. It's been coagulated. So you can imagine that the body's going to have to fix that, eat it up and chew it. not just grow back. Whereas if you look at the erbium ablation zone, there's almost nothing that you can really quantify in terms of the adjacent coagulation zone. Now, it's not zero, but it's so much less that it's impressive. Ultimately, you're going to hear from competitors that this leads to more bleeding, and that's true. And that's why we do a lot of extra engineering to make sure you can tune the laser. And we get the precise and deep ablation we've talked about, but we also have dual post technology, which allows you that independent control of vaporization and tissue heating. And this is really why this laser excels, because you get the combination of the high level of precision with the choice of whether or not you want ablation for the short pulse and a high fluence, so the heat's ejected with the tissue, or these longer train of these subablative pulses, which are below the threshold, which intentionally deposits tissue. This allows for coagulation, hemostasis. If you were to do something with ablation and coag, here's what it would actually look like. Here's our basic skin model on the left, and you're going to see laser energy coming down. And at the same time, you're going to look at the fluence of the pulses over time. So first you deposit this big ablative pulse, and it's going to eject all the tissue. There's a little bit of heat, but it resolves. Then you have subsequent coag pulses and adding in heat that you want, but only to the level you want, to the number that you dial in. And at the end, that will resolve into a certain amount of coagulated tissue. So now we really want to get into what does this mean in terms of the product. And first, we're going to cover a little bit regarding positioning. So who can benefit from laser resurfacing? If you're new to lasers or you're new to ablative resurfacing, people who are seeking improvement in their skin with desires for some tightening, or they have complaints about texture or roughness, if they want to lighten raised pigmented lesions, they can fully remove benign lesions. We put an emphasis on benign because the treatment of cancerous lesions is very special. And as a company, we would never want to make claims about that. And finally, if there are unevenness of pigment issues, you can use this for a very large number of indications. Mild and deep wrinkles are the biggest, but there's a whole lot of other things that we can really get into. A lot of these are going to fall under benign lesions. There are acne scars, age spots, crow's feet, droopy eyelids, sagging skin. Surgical scars and traumatic scars have been a huge recent effort, because doctors have been using it for years, and they're finally showing back these long-term studies to us. You can correct for sun damage and different types of keratoses, and you can see before and after pictures from resurfacing where you can see it's had a major impact on quality of life for people. When you look at us as a platform, which is one of the major pushes that we have in Cyton to make sure that people are getting everything they need out of a single box, this is gonna, and we have our diagram here with the marketing team. We have contour, TRL, and perfractional mostly showing up for wrinkles and pigment. You know, it's our 1064 clear suite and our BBL that's going to handle vascular, and then you get down here. Now, importantly, you know, BBL handles the acne when it's live with Forever Clear, and then once it becomes scars, then you go back to TRL and perfractional to get rid of them. So it's one of those things we're going to see a lot of synergy by the end of the talk. You look at the whole list of indications, you can see we can handle texture, resurfacing, scars, and wrinkles, as well as in some cases, planing down of warts. But where this really shines is when you start looking at the diagram we've come up with, where you look at like the severity of the pathology and then what is really going to treat for you. And our resurfacing suite is when they have a big condition. This is one of the only things that can solve the problem. Perfractional, TRL, or some amount of combination. But what I want to draw your attention to, and most significantly, is that because this is a tunable device, you can have downtime anywhere between 1 and 14 days, which means you're really not turning patients away. Now, a lot of times you're going to hear people pitching non-ablative lasers versus ablative lasers. And here at Cyton, we have both. And what I would say is you really need to know the details. And that's why we're spending so much time on this, so that you can help your clients to understand how they really need to utilize the right tool for the job, because otherwise they're selling treatments that aren't really going to treat the condition. Now, ablative can often be a single one and done treatment. It tends to be more aggressive, and obviously removing tissue is going to be more painful. So a lot of people aren't going to go for that. Non-ablative does have lower downtime and less pain, but usually you require multiple of treatments. And a lot of our key opinion leaders are talking about how some of their patients really prefer to be done. They don't want to keep coming back forever to get the same thing treated. Now, when you get into the laser itself, it's important to look at how these things work. Here you can see our Joule platform, and you can see different modalities being loaded into it. And for the rest of the talk, we're going to really be discussing resurfacing and how we have both full field and fractional on one platform. We have Contour TRL for our full field resurfacing, from a very small nano peel down to a fraction of a sheet of paper, like 1/25th the thickness of a single sheet of paper at 4 microns, all the way up to deep resurfacing, where we can get 200 microns deep in a single pass. And then we have perfractional, which drills smaller holes but leaves a lot of skin intact, so we can avoid some of those risks. Again, this all develops back from early risks that people saw. You realized you could not do deep resurfacing with CO2 without causing your patient significant risk, so it was ethically questionable. You can't do full field. It might not grow back, their pigment might not come back. They might end up with permanent scarring. So then they looked into doing fractional, but fractional still had its own problems because it was suboptimal because of the coagulation in CO2 that's inherent. So we have fractional as well, but with erbium. Now this lets you get to really, really deep pathologies like pitted scars or acne scars, but without ablating all the way down, because that would cause some kind of permanent damage. Finally, we have single spot handpieces, which are unsung heroes because they come with the instrument. We do our clients a service, and that way they can also tackle all the other things that walk into the office, all the medical dermatology lumps and bumps. Now, I often get asked, how can we do this? And doctors are happy with the instrument, whereas other people are not. And what I'm really going to stress on this slide is my concept that the devil's in the details. I was, as an engineer myself, with my doctorate in biomedical engineering, I was really impressed when I first came to Cyton, because unlike most of the other commercially available lasers that I could never use for my grad work, I saw that Cyton didn't cut a single corner on the physics or the engineering of the device. And this makes the treatments more reliable and repeatable, which has been echoed on every site visit that I've been to. It's really the reason why key and leading experts like to pay for our device. You will hear throughout your training that our devices are more expensive than some other lasers, but they're made with gold and rare crystals. So you can see where that's coming from. And then on top of the quality of materials, we have all the extras in our arm. We have the lasers and recollimating and refocusing lenses, so you can pass that beam all the way to the target site, imaging the same laser that comes out of the crystal. And what this really means is, as it's directed, it's able to concentrate the light, but do so while maintaining this depth of focus, which means that if you're using a TRL handpiece and maybe you breathe a little or sneeze a little while holding it away from the skin, you don't ruin the treatment. Whereas with inferior lasers, oftentimes you have to be perfectly at a certain distance to get a consistent treatment. So we design this for actual use, not hypothetical use. Attaching pieces is simple. You have a cable that identifies the handpiece. Here's your laser arm. Here's the top of your Joule system, and here's the Smart Connect cable that's going to plug into the back of the handpiece, and then the system will know which handpiece is attached, preventing any mistakes, because this is really safety. Now here you have your TRL handpiece. This is called a zoom scan, and here you have a fractional handpiece. You will see a standoff here because the light's focused to such a point that, again, it has a shorter depth of field. So that's there to guide the physician. Now on this one, you can see there's no standoff, because you can be, as long as you're within an inch or so, you're getting the same treatment. And then finally, here are the single spot handpieces for reference. And just because you're going to glide them over the skin because they don't have a scanner, you will have a standoff here to make it easier for use. We're going to briefly talk about the different hand pieces. Here you can see there are multiple different single spots available: 1 meter, 1 millimeter, 2 millimeter, and 4 millimeter spot size. The Zoom scanner has a switch on the top that allows you to switch between 4 millimeters and 6 millimeters, and it's going to scan a pattern. And finally, the Perfractional 3 scanner lays down a grid of 430 micron square holes. So to summarize, and again, we're going to go into all of this technology details and how it really works in the next module. So for this module, to really summarize, with tunable resurfacing laser, or TRL technology, you can independently adjust the depth of ablation and coag based on the patient's needs. So when your patient comes in and presents to you, you have the ability to give them what they need, no more, no less. This is all, what does this really mean? How did we make this possible? The erbium YAG 2940 wavelength is the basis. Because it's at the peak of water absorption, it results in inherently less heat and therefore historically lower complication rates than traditional CO2. When you combine that with the precision engineering of the laser arm and the erbium YAG pulse structure, it allows for selective coagulation, which prevents the bleeding that led people away from the first couple erbium YAGs that were built by some of our competitors, and also maintains depth of field so you can get exactly the depth you want, which is something that we discussed isn't always entirely possible with other laser designs, CO2 and inferior manufacturing. This overcomes the early limitations of ER-YAG lasers. So when you're out there in the field and people are saying, oh, that's shallow, don't be afraid, show them. You hear Robbie, it's a show me presentation. If you can get a demo, you're in. Now, for the next module, we're going to be talking about how this scientific baseline translates into an overall better product, building on what we learned here. We're going to talk about full field versus fractional ablation. What does that really mean, and how does the hardware differ? We're going to get into the detailed specifications and a brief overview in software, just so you have something to look at if you don't have the laser in front of you, because right now, many of us are stuck at home. And finally, we have some further learning resources, but really the best part is we're going to go into some results. And Saiton says it best, because results matter. Thank you. That's what we have for this module.